All right, let's take a look at some more coordinate geometry. So we've done some transformations, we've done reflections mainly, and translations on a coordinate plane. But we're going to look at some rules that go with those reflections and translations. So for example, if I have this polygon, this quadrilateral, on this coordinate plane, and it says transform the polygon using the ordered pair rule, x comma y, xy, my original ordered pair, to x plus 2, y minus 3. What does that mean on this coordinate plane? Well, I'm going to go ahead first, and I'm going to label all my ordered pairs. So it looks like I have negative 2, 0 right here. It looks like I have, what is that, negative 1, negative 2, negative 3, negative 4, negative 5. And it looks like I'm up to 5 for my y's. So over here it looks like I have negative 8 and 1 for my other ordered pair. All right, so what does this rule mean? What do I do with this rule I'm given over here? So I'm just going to go ahead and make a table, okay, for x and y. So if here's my xy, and here's my x plus 2, and y minus 3, I'm going to use this like any other table of values. I'm just going to follow the rule I'm given. So if my initial ordered pair, I'm going to start with this one, is negative 8, 1. It looks like I skipped an ordered pair. We'll get to that one. So if I have negative 8, 1, now over here, I want to do x, which is negative 8, plus 2. And I want to do y, which is 1, minus 3. That's going to be my new ordered pair. So if I go ahead and simplify that, it looks like I have, well, negative 8 plus 2 is negative 6, and 1 minus 3 is negative 2. So for this original ordered pair, my new ordered pair for my transformed figure is going to be negative 6, negative 2. So I'm going to go ahead and find that. So here's my negative 8, so negative 6 and negative 2. Is going to be my new ordered pair for that particular point. And I'm going to do that with every point on my graph. All right, so if I go ahead and do the next one, I'm going to go with the negative 5, 5. So I have negative 5, 5, and I'm going to follow my rule. So now I have x, which is negative 5, plus 2. And I have y, which is 5, minus 3. All right, so I'm going to go ahead and do those calculations. And I'm going to get negative 3, 2 as the new ordered pair for that second one. So negative 3, 2, 1, negative 2, negative 3, and 2. There's my next ordered pair. Right? Now this is a rigid transformation because really all I'm doing is translating. So what does the x plus 2 really mean? And what does the y minus 3 really mean? In other words, what does this rule tell us we're doing? Well, this just tells me that I am going right 2 units. Y minus 3 tells me that I'm going down 3 units. Okay? So my x rule, or x plus 2, moves me left or right. And my y rule moves me up or down, right? So if I go through and I do each one of those translations using the rule, I'm going to get a new quadrilateral. So I'm just going to finish the last 2 points by just saying right 2, down 3, right? So every x, so if I go to this one, this is the one I haven't marked, right? So if I go right 2, and down 3, that's going to be that new ordered pair. And which one haven't I done yet? I haven't done this one. So if I go right 2, 1, 2, and down 1, 2, 3, there's my new ordered pair. So let's connect those new vertices, and what I should see is a rigid transformation. So that shape looks exactly the same from the beginning to the end, or our image and our pre-image look exactly the same, they're just moved around. So again, my X rule right here is where I move right or left, and my Y rule right here is how I move up or down, and I get a new ordered pair from that. Okay, so let's take another example right here. Now this one looks a little bit different, right? So again, I'm going to do my table of values, and I have x, y, and now I have x negative y, or the opposite of y. So let's take P. Because the ordered pair for P is going to be -1, -2. Whoops, -1, right? I'll make that a little more clear. So what is my new P prime going to look like? Again, that image is going to be called prime, right? So you use that hash mark for your prime is going to be x negative y. So it looks like x remains the same, x and x. So my x value is still -1. But now it looks like my y value is the opposite of what it was before. So now I have -2 for y here, and it's the opposite of y, so this is going to be +2. Okay, so all this is doing is flipping my y's from a positive to a negative, or from a negative to a positive. It's using the opposite of whatever that y value was. So my P prime is going to be -1 and 2. Okay, so I'm going to label that. I'm going to go all the way through this one, and then you'll see what type of transformation this is. So I'm going to go to Q. So what was Q before? Q was, let's see, 2 and -1, 2, 3, 4, 5, 2, -5. Okay, what is Q prime? Again, x remains the same, so x is still 2, and y is the opposite. So it was -5, the opposite of -5 is +5. So now I have 2, 5. So 2 up, 1, 2, 3, 4, 5. So there's Q prime. All right, let's get rid of that. Let's just finish this one off. So now I have R. My original R is, let's see, 1, 2, 3, 4, 5, 6, 7, and -3. Okay, and again, R prime, x remains the same, and y is the opposite. So 3 instead of -3. So I have 7, 3. Okay, so let's do that in green. So I have my R prime. All right, and now finally I have my last point is going to be, let's see, I haven't done S yet, right? So S is 3, 1. And S prime, x remains the same. For this rule, x is still x, but y is the opposite. So I'm going to go from 1 to -1. So now I have 3, -1. Okay, so there's S prime. Now if I look at this transformation, see if you can figure out what's actually happened. So I'll go ahead and I'll connect my vertices. What does it look like has happened? I'm going to kind of look at that larger angle, right? So look at Q. Here's that larger angle. And down here on your original, your image, the larger angle is down there, right? So is this a translation? Have I moved every point the same number of spots, up or down, left or right? Or have I taken the original and have I flipped it over? Well, if Q started down here and Q prime is up here, it looks like what I've done is actually flipped it. So this is a reflection. So when you see this type of rule, where one of your values is changing signs, it's not moving up or down, left or right, that's going to be a reflection. So the other one was a transformation, and you can see that's going to be plus something or minus something. When you see a rule where one of your values is just changing sign, it's just the opposite, that's going to be a reflection. Now this is a reflection across the x-axis, this one, right? So it flipped from down here across the x-axis up to here. That's a reflection across the x-axis. That's the line of reflection that it's flipped across. So when my y is the opposite of what it was before, it's a reflection across the x-axis. Okay. So if you take a look at, let's see, do we want to do this one? This is just our solution for the last one. So every x-coordinate stays the same. Every y-coordinate changes sign. Again, reflection across the x-axis. So you could say if all the x-coordinates change sign, that would be a reflection across the y-axis, right? So let's just take a look at one more. I'm going to transform using this rule. This one's a little bit different. So I have xy, and then I have y negative x. So what is happening here? It looks like my values are switching places. So if s, no, let's not start with s, let's start with r. So if r is at 2, negative 2, what do I want to do with them? I want to switch them around, okay? So if I switch them around, it's going to be negative 2, 2. However, my x value has changed signs. So in here, x is a positive 2. So my original r, x is a positive 2. But in my new one, I need the opposite of that. So x is now a negative 2. So my new point is negative 2, negative 2. Okay, so here's r prime. If I do that for each and every point, let's just do one more. So here I have for q, negative 1, negative 1, negative 4. Oh, and I should call this r prime. So what's q prime going to be? Again, I have to swap these around, but I also have to make the x the opposite sign. Okay, so if I switch them, I'm going to have negative 4 first, and then x has to change sign, so instead of negative 1, 1. So q prime is negative 4, negative, oh, not negative 1, positive 1. So there's my q prime, all right? If I keep going, switch the values and make x the opposite, or the negative, what is this going to look like? So what's happening here, so here's my rule, take every x-coordinate, change its sign, and it becomes the y-coordinate. Every y-coordinate becomes the x-coordinate, is what we were just describing. What this is, well, this is not a translation, it's not a reflection. You can see from your final image that this is a turn. So this is a rotation. So when you see those values flipping around, when the x and y are in the opposite positions, that becomes then a rotation rather than a reflection. So when you see a rule like this, or something like this, they could look a little bit different. That's going to be a rotation, right? I think we're going to stop there, and we'll do the rest of the examples in class.